8.6 is law of sines and cosines. Have you written the title down already? Okay. Intro stuff. A reminder about what we've learned so far this chapter. When we learn, like to begin with, Pythagorean theorem, what kind of triangle did that have to be? A right triangle. For our special right triangles, what two angle measurements could we use? Yep, the 45, 45, 90, and the 30, 60, 90. So those have pretty specific requirements. And last time, and the time before, when we worked with SOHCAHTOA, what kind of triangle did it still have to be?
Right.
Yeah, it had to have a hypotenuse, so it had to be a right triangle. So we were a little restricted, as in everything that we've learned to do so far with triangles required it to be a right triangle. So if I asked you to solve for something and it was a non-right triangle, would there be anything you can do?
No.
The Pythagorean theorem is not going to work. It's not a 30, 60, 90 then. It's not a 45, 45, 90. The trig identities, like the theorems that we've learned as far as SOHCAHTOA, that stuff's not going to work. Today, though, the trig that I'm going to teach you can be used to find missing measures in any triangle. You could use this stuff for a right triangle, but I don't know why you'd ever want to do that because it does take more work. And it's kind of like what we've had so far. Like if it was a 30, 60, 90, then we'd probably just use those rules because that's not a lot of work. If you know what those ratios are, you either multiply or divide. There's not really any algebra to do. If we knew two sides and it was a right triangle, we're probably going to use Pythagorean theorem. This is kind of our last effort. Like if it's not a right triangle and none of the other stuff works, we'll either use the law of sines or law of cosines. And I'll teach you when we learn to use which one when. Is that the other fancy law? Yeah, tangent, like if you ever take the trig course, there's a lot with it like that we learned. It's kind of different. Like the graphs of sine and cosine look pretty similar. Tangent is completely different. And a lot of other things like sine and cosine kind of have in common, but tangent's kind of out there. Law of sines is what's up here now. And it is a series of ratios that are set equal to each other. In chapter 7, what did we learn? That when you set two ratios equal to each other, what's that called? Portion is right. So we've got a series of ratios, and they form a portion. In any triangle, if you take the sine of an angle over the side that's opposite it, it'll be equal to the sine of a different angle over the side opposite it, equal to the sine of the last angle over the last side. Like what we've already established, when we're using like the capital A for the angle and the lowercase a for the side, those need to be opposite of each other. When we drew those out in 8-4. So angle A, opposite side A. Angle B, opposite side B. Angle C, opposite side C. Once you have that equation written down, go ahead and draw this triangle with me. If you started to write this, why don't you wait a second on that part. Go ahead and draw the triangle. You can finish it, but I just want to look at the triangle first.
Will you both after that?
I do want you to write it, just not yet. It'll make more sense if we have the drawing first. So label that triangle as triangle ABC. Make sure you get your vertices labeled in the same position as mine are. Where does side A need to be then? Between which two?
A and B.
C and B. Why did it have to be over there? Yeah. Angle A is here. Side A is opposite. What about side B? In between A and C. And then the last one would have to be down here. And we're going to need to think about triangles like that to use these laws. That this angle is going to have a side that's opposite it, and so on and so forth. So now you can go and write down that sentence or finish writing if you haven't yet. The law of sines is used when you know two angles and one side. And that could be either angle side or angle side angle. It doesn't matter if the side is included or not. If you know two angles and one side, this can be used. Or a more specific case, two sides and the angle opposite one of them. For two sides and the angle opposite one of them, or SSA. Particular reason why I wrote it that way. What you're going to need to be able to recognize is when this law works. So you could either have two angles in one side. Does it matter where the side's at? No. It can be in between them or it can be outside of them. That doesn't matter. If you have two sides, the angle that you know has to be the opposite one. Doesn't matter which one it's opposite of. So let's look at how it's going to work. We're going to do two examples of law sines to illustrate what that can look like. Then I'm going to show you law cosines, and we'll do two of those as well. Do you see those numbers okay with the lights on? Yeah. Yeah. One side's 8. We're going to find x, which is that other side. We know this angle is 17. We know this angle is 29. Because they're not right.
Yeah.
Yeah. Yeah. Let's see what we did here.
If you didn't have the
Well, yeah, but since we know 17 and 29, can we figure out the other angle? Yeah. So I know for sure it's not a right triangle. We can definitely verify it's not. What we've got, we have two what kind of things that we know. And we have a, do we have angle, side, angle, or angle, angle, side? Why do you say that? And the side is not
Fair.
in between. Yeah, it's not there. It's not in between them. So we've got angle, angle, side. So can we use the law of sines?
Yeah.
When you set this up, I usually pay attention to begin with what is it I'm trying to find. So that's the x. Which angle is opposite the x?
17.
So it's going to be right this way. Sine of 17 degrees over, what's the side across from it? X. Equals, the other ratio would be the sine of
29 over 8.
There you go.
is this like as hard as this?
For law sines?
Yeah.
There might be some if we need to find the angle. What do we learn to do to get rid of the sine?
Negative.
So that'll come up on the next one. So that's a little harder maybe because there's one more step.
Yeah.
But this is typically what it looks like.
Crosswalk.
Exactly. Because it's a proportion, how have we learned to solve those already? Well, it's crosswalk. So we're going to do that just like we've learned to do already. So I'd write it as 8 sine of 17 degrees equals x sine of 29 degrees. What am I trying to get by itself? So what's the other thing I need to get rid of?
Sine of 29.
How would I get rid of that?
5.
There you go. So divide both sides by sine of 29. Like what we've done last section, the section before, what tool can you use as soon as the variable's by itself?
Computer. I need your
I can use my computer, you can use your calculator. Kind of the same thing. So type it in like we just wrote it. 8 sine of 17. You know, some of you before were like, do I really need to close those parentheses? Now it really matters. So make sure if it generates those there and there, close those up.
4.8. Wait, I didn't get to
Can we put parentheses on the outside of our sign? You know what I mean? Like before we hit
It's not wrong to do that. On this one, it's not necessary.
I'm gonna do it anyway.
4.8. I didn't get that.
Okay.
That's what I got.
We'll try it out up here. So I got 8 sine 17, close it up, divided by sine 29,
Oh,
close it up.
it was 29, not 24.
4.82.
That's what I got. And what were we told to round to?
Years.
So it would be 4 point. I agree. Was everybody able to get that now?
I figured that one. I put 29 for.
After seeing that, I kind of like what I'm hearing somebody say. It really shouldn't be too mind-blowing. Are we pretty used to working with sine by now?
Yes.
That's not new. Are you pretty used to cross multiply solve?
Yeah.
Yeah. So it's just kind of combining two separate things, and now we can do stuff like that. So now we know that's 4.8. We don't need to on this one because we weren't asked to. But could I now, if I needed to, find that angle?
Yeah.
I could subtract these two away from 180. And then can I do law of sines again to find my last side?
Yeah.
Yeah. So you can find everything you need as long as you got those three things to begin with. Do you have any questions on that before I look at the next one? No. Okay. Next example. These sketches first. And again, find x, but this time we're going to round to the nearest degree, so that would imply x is an.
Right angle. Right
No.
triangle. I don't know.
What kind of thing is x?
Any
Yeah,
variable.
it's an angle. And as we already established a little bit ago, whenever we find the angle, what do we end up doing as our last step? The inverse. It's going to be nearly identical to what we just did. We're just going to have to do the sine inverse of that stuff.
So we're gonna do sine. Right.
We can start that way. I'll wait till I think everybody's got it written. Yeah. So like I said earlier, what I would advise you look at first is what you're trying to find. And since it's an angle, it's going to be, like somebody said, sine of x over, what goes with that? 11. And then that should equal, what would the other ratio be?
Sine of 50 over 10.
That'll definitely work.
So you go with what's opposite.
Yeah. Now I should have mentioned this earlier. Why we can use law of sines is how many sides do we know?
2.
And how many angles?
2.
So we're not
One. So it's SSA.
Sorry.
And the reason why it's working is, isn't the 50 across from the 10?
Yeah.
And that was that last note we had on that reason why it would work.
So we're not gonna do like what we did last time, instead of like sine of x equals. We're not gonna do
We'll still cross multiply. Well, let's go ahead and do that first. Go ahead and cross multiply. What would be on the left side now?
sine.
10 sine
10 sine of x would equal.
11 sine of 50.
Now keep in mind all along, what are we trying to get by itself?
Yeah.
6.
How about I move to 10?
Divided by.
So divide both sides by 10. It's going to cancel, but now I got to do it on the. Yeah. So now I've got sine of x equals 11 sine of 50 over 10. What do we do to make the sine go away? What you tell me earlier?
No, the negative one.
Yeah, the one with the negative 1, the sine inverse. And if I do that to the left, I got to do it to the.
Right.
So now we're ready for our calculator. X will equal, write this exactly as I do. Sine inverse, parenthesis, 11 sine of 50,
Divided by sine.
close those, all over 10. You need to have the parentheses around that like I wrote. If you type it without the parentheses, the calculator will not do what you want it to do. And you'll probably get some kind of error.
Right. I haven't solved it yet.
Okay, so I'll type it with you. So I'm going to hit second sine to get my inverse. I'm going to do, it already started the parentheses, so that's okay. 11 sine of 60, close it, divide by 10, close it.
50. 60.
Oh, 57.4. I thought that was 50. 57.4. Yeah,
I typed 60. I did type 60. That was looking a little big. I was just checking to see if y'all paying attention. Yeah, I guess my parenthesis and my 5 kind of merged there, huh? So 57.4,
Yeah.
what were we told to round to?
10.
So it would just be
57.
just 57. Nearest degree, so just 57. So x is 57. From there, we aren't going to, but if we needed to, now can I find the other angle?
Yeah.
Yeah.
You just subtract them from.
Subtract them from 180, and then can I use the law of sines now to figure out my last side?
Yeah.
Yeah. So if you're ever asked to find everything, that's how that goes.
Ooh.
Do we feel okay with that?
Yeah.
When is the only time you'll use the inverse? When you're finding the number of degrees, the angle. Yep. All right, other law then. Law of cosines. It ends up being a lot of calculating work again. So do not be intimidated by the fact that it's a longer equation. It's look at what you got, plug stuff in, type it in, get things. A squared equals b squared plus c squared minus 2bc cosine of a.
Is that a space between those?
Yeah, and the space just represents its multiplication. So it
Oh.
may not hurt to put like parentheses around that or something. That'll help. The 2, the b, the c, and the cosine of a all are one term getting multiplied together. The law of cosines, like the law of sines, has some particular places where it gets used. It gets used if you know two sides and their included angle, so SAS, or if you know all three sides. So it ends up being a pretty powerful tool, especially in the last case. What this will let us do for any triangle, if we know all three sides, what are we going to be able to figure out? All three. There you go. So if we don't know a single angle, we can use this tool to figure out what they all are. I probably use this once to find one. Then I probably use law of sines to find another. And then I can just take the 2 I found away from 180 to find the third. Lets us figure out some things that we would not have had any clue about before. Ready for the first example of this? Okay. Another triangle. We're going to find x. What kind of thing is the x this time?
Side.
Yeah, it's a side. And then we're told to round to the nearest 10. It is 45. I'm glad you mentioned that because I want to bring that up. And I actually made that 45 for a reason. What did a lot of you probably think as soon as you saw that?
45, 90.
Can we use that here?
No.
Why not?
There's no 90.
Yeah, there's no 90, and I don't know the other one. Like, I know 45, but does that mean the other ones have to be 45?
No.
If I knew that one of them was 90, for sure, then yeah. But I cannot use that here because it's too many. 8 could be. And unless I know it for sure, I do not want to use something that I can't use. Ignore the x for a second and look at the 11, the 45, and the 25. Why is it okay to use law of cosines? Because I've got,
Side angle side.
yes, write that down. We got side angle side. So this is kind of textbook classic law of cosines. Exactly what it needs to be. The equation, let's go ahead and write it again. It said a squared was equal to b squared. Keep going. Now just that part, does that look a little familiar?
Yeah, it's the high back here.
It's a derivation of that. Like it really is based off that. What comes next?
Minus
Minus
2bc
cosine of A.
So jot that down.
Are we able to memorize that?
Unfortunately, yes. For the EOC, like for whatever reason they didn't put this on there ever, I will, like for your test, like I'll put it on the board. So like for something like ACT, unless you put it in your calculator, like it just be one you need to know. It's a lot like, to begin with, like, I think you guys asked me the same thing though, like with sine, cosine, and tangent, where you're like, do we really have to memorize this? And how many of you have that memorized by now?
I don't know, but no.
Like, didn't it just kind of happen? And I think this will kind of be the same way, like as bad as it looks. After you practice it a few times, you just kind of start to remember it.
And we basically already know that.
Yeah, and then that it's Pythagorean theorem plus a little bit more. In our case, we're not finding a though, are we? We're finding x. So that's going to go there. X squared. What could the b equal in this case? Could be the 25, sure. So 25 squared plus 11 squared minus 2 times, what did I already plug in for b? So that's going to go here. What did I already plug in for c? And then times cosine of, what's our angle A then? 45. And I want to take a little time to identify where things need to go when you do this.
I thought A was X.
The little a is the
No.
side. What's the big A? That's the angle. That help? Now the reason why they're both A is the same reason we've been talking about. How do they relate to each other? They're opposite. So whatever goes here in the front, like the little a, this angle has to be the one that's opposite of it. It can't be some other random angle. Yeah.
Are the sides and stuff gonna be labeled on there as letters?
Like,
Stuff?
yes. I think that'll help.
Yeah.
I don't know if they always use A's, B's, and C's, so I didn't bother doing it. But I think it's all. All right. Now we just have a lot of work. I think we can do this in 2 steps. So I'm just going to write x squared down. Are there any variables over here at all?
No.
So do I have any algebra to do on that right side?
No.
So could I just type all that in at once?
Yeah.
That's what we're going to try to do. So why don't you hold up a second until I got mine on the screen. That entire right side, I just want to type in as one quantity, figure out what it is.
Did you say right side?
I did say the right side.
You mean all of it?
I do mean all of it, yes. Starting with the 25 squared all the way down to cosine 45. So type it with me. 25 squared plus 11 squared minus 2 times 25 times 11 times cosine 45. I don't know. Me too.
Would you like it?
Try again, then.
I got 357.
357.09. Yep.
Is that right?
So we don't have to add any.
Unless we
Like,
both did it wrong.
we don't have to add any parentheses in there.
No new ones now.
Why is
A lot of times, Ryan, like the parentheses, you need to interject in there whenever you're doing division. Tell it like what's in the numerator, what's on the denominator.
you have to square it because there's a
Exactly.
square root? I was
'Cause
like,
this
why
is x
that
squared,
big?
isn't it? That's not what we want though. We want just regular old x. And isn't that a lot like the Pythagorean theorem?
Yeah.
Do I need to type in that number? No, on most your calculators, hit square root, and then do like second, like on the graphing one's the negative key.
Negative.
If you use second negative, what did it put there?
Answer.
Yeah, and what do you think that is? Your last.
Yeah.
It basically copies and pastes what you did.
18.0.
If you don't have that on your calculator,
What do I do?
Why is
just
it
type in square root 357.09.
I have a graphing calculator. Mine doesn't do that.
Yeah, it does.
Mine didn't do it when I
I
did.
got
We have the same one.
No problem. Which answer is better on my screen? The first one or the second one? Well, are they exactly the same? Look at the end. The first one's a little bit more accurate. If we're rounding to the nearest 10, doesn't matter. It's going to be 18.9. So that's my answer. If you can avoid rounding until the very end, though, that'll help. So we got x squared was 30 or 357.09-ish. Then we took the square root, and we got that x was equal to about 18.9. Just like before, look back at your original problem. Does that seem reasonable? Yeah, I'd say so, because we had 11, we had 25. Yeah, that seems like right in line. That seem okay?
Yep.
What's really important, though, how does this match up with this angle every time?
It's the same.
They're the opposite.
Or opposite.
Yes. And then these are just the other sides. Looking at last example then. Yeah, it seems like you guys are getting it pretty well. So That helps.
So I thought about the last one. That's what makes me get excited about it.
What info did I give you on this triangle? Side. So which law fits?
Law cosine.
Law cosine. Well, will be like an extra little challenge on the homework or the quiz. It's not going to tell you which law to use, but as we've been going through these, you know, how to making you think about, oh, this is why we're using that. You'll just have to think about that on your own.
I'm not good at thinking on my own.
Are you good?
You're better than you think.
No, I'm not, Ryan. I heard that.
So we definitely have side. With this, we're again going to use the law of cosine. So I'm going to write it down. A squared equals, how does it go?
B squared plus B squared minus 2BC cosine.
Yeah. Law of cosine. What has to go in for
I don't
little
know
a?
what's A, B, C.
What has to go in for little a?
The X.
No.
27.
Oh,
24.
Why the 24?
Because it's opposite.
It's opposite what we want.
Oh.
That's how you make that decision. So the 24 goes there. Does it matter the other two B and C?
No.
Okay. So 24 squared will equal, could be 27 squared plus 5 squared minus 2 times 27 times 5 times the cosine of
X. Oh.
a little different this time, right?
Yeah.
Yeah, it looks worse than it is, though. I really. Because think about, that's just a number, that's just a number, number, variable. So rather than just typing it all at once, we do have to do a little bit of algebra. So let's break it down.
We can do it alone.
Do 24 squared. Tell me what that is real fast.
24.
No.
Yeah.
576.
576 is right. Now could we go ahead and add those together after we square them?
Yeah.
So do 27 squared plus 5 squared. You can do those, Simon.
754.
754. That was after you added as well? Okay, so 754. So this became that. Together, those became that. Could I do 2 times 27 times 5?
Yeah.
Go ahead and do that. So minus, what's 2 times 27 times 5? 270 exactly. Okay. So those three combine to become that.
And you'll have cosine X.
And then I just have cosine x. Now think about that like it's a variable. How do I get rid of this positive 754? Subtract it from both sides. So minus the 754 from the,
Wow, that's going to be a negative number.
it is, but we'll deal with it in just a second.
Oh.
What is 576 minus 754? Negative
178.
negative 178 equals, what's still on the right side? Negative 270 cosine of x. How am I going to get rid of that negative 270?
No, multiply, dot, square it, dot.
What's that doing in this?
Multiply.
So to get rid of it, I need to divide. And if I divide the right, I need to divide the,
So 178 divided by 270.
well, it's a negative or a negative, so
Positive.
Oh, are you okay?
yeah. So give me that.
0.6.
Actually, don't give me that. You're going to have to round, right?
Yeah.
Let's avoid doing that.
Oh.
We do know it's going to become positive, right?
Yeah.
So I'm just going to leave it as a fraction. Let's just leave it as 178 over 270. I could reduce it, but I don't need to, so I'm not going to bother with it. So I've got 178 over 270 equals cosine of x. That could have been a question on your quiz today, right?
Uh-huh.
What's the last thing to get x by itself?
You divide.
The inverse. So x is going to equal the cosine inverse of 178 over 270. So practice typing that in with
And how many more?
second cosine.
No,
one.
48.
Shh.
I was like, wait a minute.
Don't.
She doesn't have the answer
I
yet.
want to figure out what
She
she
wants to
is.
figure out what it is.
Well, she can still figure it out. She can calculator.
So what are we gonna round it to?
49.
49. We have 48.7. Yep. So x equals 49 degrees. Were we able to get that at the end?
Yes.
When you're finding the side, I would type it in all at once and then take the root. When you're finding the angle, you can't really do it that way because the variable's with stuff. You okay with how we broke it down, moved stuff over to algebra?
48.
That's how that works. Everything you'll be asked to do on the worksheet will be one of those 4 examples. Law of sines, finding a side. Law of sines, finding an angle. Law of cosines, finding a side. Law of cosines, finding an angle. Yes.
I'm so confused on like why you can't type in this whole thing, but we can type it. Because there's no variable.
Yeah. On the first one, the variable is over here on the left. So that right side was just numerical. There were no variables whatsoever, so I could just punch away. Whereas on this one, I can't do that because this is stuck with it. So as long as this is with the numbers, I can't use my calculator. But as soon as the variable was by itself, what can I use? Yeah, and that's maybe a good way to think about it. You can't use the calculator to type all of it in until the variable is by itself. While the variable is there, things going on. Like here, to get rid of that 270, I needed to divide, but if I had just done all that, that would have been all messed up. Guess what? All right. So I'll get worksheet passed out, and then